All right. So hopefully everything goes smoothly today. So today, learning objective is I can recognize and extend geometric sequences. So first things first, what is a geometric sequence? In a geometric sequence, each term is multiplied. That's very important, multiplied. Multiplied by the same number to get to the next term. So first things first, any list of numbers is a sequence. It can be anything like 1, 2, 3, 2, 4, 6, yada, 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 so on. So what makes it geometric is that thing right there. It's multiplied by the same number. So in this example right here, to get from 3 to 12, we're multiplying by 4. Same thing from 12 to 48, and 48 to 92. Okay? So that multiplying by the same number, this thing right there, that's called the common ratio. So to find that, first thing you have to do is you have to divide whatever term you want. So for this one, 54, you have to divide that by the previous term, the term that came before it. So right here, 54 divided by 18, because 54, term that came before it is 18. 54 divided by 18 is 3. So that's 1. So next one, 18 divided by the previous term. That one's 6. 18 divided by 6 is 3. And the last one, 6 divided by its previous term, 2. 6 divided by 2 is 3. So there's kind of a pattern here, isn't there? Each term, when it's divided by its previous one, gives us an answer of 3, right? So that's what the common ratio for this sequence of numbers would be. The common ratio is 3. So we have to figure out, one thing we have to figure out is how do we tell if a sequence is geometric? How do we tell if it's being multiplied by the same number or what the common ratio is? So for this one, 5, 10, 15, 20, just what do you guys see right away when you look at it?
It's not a geometric sequence
Okay, why?
because there's no, there's like, not one number the same like the other one. Like the one on the left has 3, that one has 3 different ones,
Okay,
3 different answers.
right, there's 3 different common ratios. So when we divide 20 by 15, because that's how we find the common ratio, we find one term, and we divide by the previous term, the one that came right before it. So 20 divided by 15, that gets simplified down to 4/3. And do you have a question?
No.
Oh, sorry. My bad. All right, so 20 divided by 15, that gets reduced down to 4/3. And we can't go any smaller than that, can we? No. So that's the ratio for this one. So what's the next one? 15 divided by 10, it gets reduced down to 3/2. And then the last one, 10 divided by 5, that gets reduced down to 2. So these aren't the same, are they? 4/3, 3/2, 2, not the same? No. So because that the ratios that we found, they aren't the same, there's no common ratio, so this isn't a geometric sequence.
Quick question, because it's a review, we should know this, but we're gonna have to dig back to last year, so let's see if we can. What is happening in this sequence? 5, 10, 15, 20. It's going up by halves, 5, 5.5, 6, 6.5, 7.
It's going by 5.
Going up by 5s, 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20. Oh, this is a special kind of sequence, it's not geometric, because there's not a multiplier, there's something instead of multiplying by the same thing, we add the same thing. Anybody remember what kind of a sequence is it when we have a common difference? An arithmetic sequence, good job. This is an arithmetic sequence, this one. We're looking to see if it's geometric, it's not, but it does happen to be a special type of sequence called an arithmetic sequence. Trey,
If we're adding 5, isn't it still a common ratio?
is that a common ratio? What does ratio mean? A rate, okay. So did we get the same rate every time when we took a term and divided it by its previous term? Did we get the same rate every time? No, we didn't, did we?
But we're
So is adding 5 the same as multiplying by 5?
No.
No, it's not, is it? So ratio means that you're comparing two numbers. When you divide the numerator by the denominator, you get to your actually divided out ratio, which if you want to call it a rate, you can call it a rate. And that has to be the same. That is not the same as adding. A ratio is not adding, is it? Ratio is dividing. And the inverse of dividing is what?
Subtraction.
No, multiplication, okay.
Alright. So, these next few problems, first thing it says, determine if each sequence is a geometric sequence and show support. So, we just went through how we determine if something is a geometric sequence. We find the common ratio. So, we have to have one term, and then we divide it by the previous term, the one that's right before it. So for this one, 4. 4, we divide it by the term that came right before it. So 8. What's 4 divided by 8?
2.
2?
1/2.
1/2. Right. Okay, so that's the first one. So then we take 8 and divide by its previous term, the one that came right before it. So 1 comes right before 8 is 16. What's 8 divided by 16?
1/2.
1/2. And then lastly, 16. Oops. 16. Divided that by the term that came before it, so that one's 32. 16 divided by 32 is?
1/2.
So, do we have the same ratio between each one, between each term?
Yes.
Right. So is this a geometric sequence then?
Yes.
Yep, so we would say yes. This is a geometric sequence. A geometric.
Brighton?
Okay, so would it ever be possible to go backwards like 32 over 16 and 16 over 8 and 8 over 4?
You could try it.
So say that again.
Have 32 over 16.
Okay, I'll just do it over here.
You're gonna get 2.
Mm-hmm.
All of this gonna be.
So that equals 2, 16 divided by 8, that equals 2. So, what Brighton just found is what we're multiplying to go this way. No, we're not, because 8 times 4, or 8 times 2 is not 4.
Okay, what happens is when you do it that way, it better work then as the multiplier to move from left to right. Does that work as a multiplier moving from left to right? Is 32, the first term, times 2, the second term, 16?
No.
No. So we have to make sure we find, what we're doing when we find the common ratios, we're actually finding the multiplier. So let's see if our multiplier that we found is good. This is how you can check yourself out to see if you have if you did it right. Is 32 the first term times our common ratio 1/2? Is it the next term 16? Is half of 32 16? Is half of 16 8?
Yes.
Is half of 8 4?
Yes.
Then what do you think is the correct common ratio? 1/2 or 2? 1/2, yeah. We divide to find the multiplier, but we have to divide in the correct order because division is fussy. Ms. Brighton?
So then, I know this is kind of weird, but then couldn't we take that 2 and do 2 times 4 and get 8, and then 8 times 2 and get 16?
We could. What if I ask you to find the fifth term of that sequence? What are you going to do?
2 times 32.
Really? Okay, what is that?
64.
64. So you think the next term, the fifth term of that sequence is going to be 64? What do you think, class? You think the fifth term is going to be 64?
Yeah.
No.
No. So we need to work from left to right to get more terms, don't we? So it's important that we have the correct multiplier so we can move from left to right. To find that multiplier, we have to work from right to left. We have to see what happened. We have to undo what was done. We're doing the inverse. We're dividing to get the multiplier. So we need to get the multiplier so we can keep working from left to right to get more terms. Does that make sense? Okay.
All right, so said this was a geometric sequence, and then the last part we have to say is that 1/2 is the common ratio. Because that's what we're multiplying each term by to get the next one, right? All right, pretty huge. All right. So now we're on number 2. We have to determine if it's a geometric sequence, so how do we do that?
32 divided by -16.
So we have to take the last term, which is 32, and divide it by its previous term, which is right before it, so that's -16,
-2.
-2. Okay, then we just keep moving backwards, so -16.
I'm sorry.
We're looking.
Okay.
I thought we were going to Monterey.
Yes, this is
And then the last one, a divided by -4 equals -2. So we work backwards, so the last term, 32, one right before it, the previous term,
Okay, so it doesn't matter to you.
-2, so it is a geometric sequence.
And -2 is the common ratio.
And this should have been like, you should have been zero. Right? I did that.
Yes, Emerson?
So now in our homework, do we have to write that out, like this, the combination, and this is a
If it says determine if the sequence is a geometric sequence, you would say yes, it is a geometric sequence, or no, it is not a geometric sequence. If it is, then you should probably give the common ratio too. So for these ones, the common ratios were 1/2 and -2, so you should probably put that on your homework too.
So I'm guessing what he just said to you, Emerson, is yes to the answer to your question. Do you have to write all that out? And he is saying, yes, you do, right?
Yes, Trey?
Are there any abbreviations?
Are there any what?
Abbreviations.
It's good to practice your English skills too. All right.
You have English.
All right, so move on to number 3. So find or determine if that is a geometric sequence. You guys do this one on your own.
Yeah.
So what is the first thing you have to do?
When they don't divide out to be integers, just leave them as simplified fractions. Do not change them to their decimal name. Simplify them as fractions, just like they did in the example above where they ended up with, well, I guess they don't, yeah, the one on the right where they ended up with like 4/3 and 3/2.
All right. So, find if something is a geometric sequence. We try to find the common ratio, so we take one term and divide by the previous term. So 8 divided by 6 is 4/3. Then the next one, 6 divided by 4, that's 3/2. And then the last one, 4 divided by 2 is 2. So, is this a geometric sequence?
No,
Nope, because these aren't the same numbers. We're not multiplying by the same number to get the next term, are we? Nope, so,
And being as bright as you are, you can all tell me what kind it is, can't you? What kind is it?
no combination.
No, what kind is it?
what kind of sequence is it?
Oh, non-geometric?
Yeah, that's
Oh, yes.
true. What happens in this one?
They're all going up by 2.
They're all being added by 2, right? You're adding 2 every time. What kind is that? It's an arithmetic sequence with the common difference being positive 2, yeah.
All right. So, we said this, yes, Brighton?
So, if we find that one of them does not match, can we stop there and say it's not a geometric sequence?
Good question. Well, you should probably do the last one just to make sure that they're all different. Because even if one's different, maybe something happened, but I would say, yes, you should go through all of them, just so you're positive that it's correct. So, this isn't a geometric sequence, so we say not a geometric sequence. And then there's no common ratio, just like we saw, so we can just write no common ratio. All right. So. All right. We're on to the last one, so you guys do that one by yourselves too.
Go ahead and use your calculators for it, it's okay. Get decimals in it.
I don't even know.
Zero's not one term. It's 0.4. Previous term is 2.
It's,
That's 2 times, right?
Like,
Okay, that's okay. You can get it, by the way, your common ratio can be, or your ratio, doesn't necessarily have to be common, your ratio can be a decimal. It's okay. As long as it's a nice decimal, a terminating decimal.
Yeah.
So that's 2 times, right?
Oh, yeah.
there we go.
All right. So, someone tell me, is this a geometric sequence?
Yes.
Yes.
Why? These aren't the same, are they? 0.2? They don't look the same. Cameron?
0.2 is the decimal form of 1/5.
Right, because this says 0.2, that's 2/10, because right after the decimal point is the tenth place. So this is the same as 2/10. And just like Cameron said, this simplifies down to 1/5. So even though you might get decimal answers or fraction answers, as long as they're the same thing, your geometric sequence should work out.
Does it matter which way you give it then? If it's a nice decimal that terminates, does it matter if you say the common ratio is 0.2 or 1/5? Does it matter to you, Mr. Conlon, in their homework?
Nope.
Okay.
As long as it's one or the other, I'm fine with whatever. So, we said it is a geometric sequence, so it is a geometric sequence. As I don't give myself enough space. Geometric sequence. And, oops. What's our common ratio for this one?
0.2.
0.2 or
1.2.
Okay.
1/5 is the common ratio. Wonderful. So before we move on, does anyone have any questions about how to determine if a sequence is geometric or not? Okay. Now, we can move over to the next page. So, the next part is telling us to find the next three terms in the geometric sequence. So, it already tells us that it is geometric, right? So, if they tell us it's geometric, we probably don't have to find the common ratio, because there should be one, right?
Well, we have to find it.
Yep, we still have to find it though, because,
We
Just
still need
having-
to do it 3 times.
yep, so, first find the common ratio, take the last term, 64, divide by its previous term, and that's 16, and what do we get?
4.
4, yep, right there, and just keep on going, so 16 divided by 4, that equals 4, and then last one, 4 divided by 1, equals 4. So what's our common ratio?
4.
4. As I completely block it out. There we go. So, our common ratio is 4. Now, we're asked to continue the sequence. So, if we want to find the next one, what would we do to our last term, 64?
Multiply it by your common ratio.
Exactly. So, 64, our common ratio is 4. 64 times 4 is 256. So, that's our fifth term, or our first one that we're finding. And we just keep going until we find the next three terms. So 256 times 4 equals 1024. I'm really bad at this. And 1024 times 4 equals 4,096. So the next three terms are 256, 1024, and 4,096.
Can I just clarify what I think he was trying to tell you at the beginning here? Because I know that they're not understanding.
Okay.
He is saying that since they're telling us it's a geometric sequence, we should not have to do every one of these, all 3 of them. You should be able to do one of them. Pick a term in the sequence, divide it by the previous term, and you'll have your common ratio. So do you have to do all 3 of these? No, you can pick this one. Say, I'm going to find my common ratio using those 2 terms. Or you could pick this one. Or you could pick this one. You don't have to do all 3. When they tell you it's already a geometric sequence, that's a lot of extra busy work we don't need to do. But then you do need to do all 3 of the multiplications to get your next 3 terms. Okay? Okay, I'm sorry.
No, you're fine. All right, so last few problems before we start our homework. It says find the common ratio in each geometric sequence below, then find the next 3 terms. So, just like Ms. LeGrand said, they tell us it's geometric. So we just have to find the common ratio. So, someone tell me what term to use.
5.
5, okay, so Shamarky wants 5. So what's the previous term for that one? 1 divided by its previous term. 5 divided by 1 is? It's often 5, so there we go. Is the common ratio. Alright, so now that we found our common ratio, we have to find the next 3 terms in our geometric sequence. So, the last term they gave us is 125. So how would we find our next term? Divide by 5?
Multiply it by 5.
Okay. So, who agrees with Shamarky that should be divided by 5? Oh, you're gonna change your answer? Okay. So 125 times 5. What's that equal?
625.
625. Alright. So that's our first term that we found. To find the next one, we do the same thing. We take this 1 times 5. What's 625 times 5?
3,125.
Is that what you were gonna say, Stefan? Alright. 3,125. So that's our next 2 terms. We need 1 more. So we do the one last step. And what's that come out to be?
15,625.
15,625. All right.
So would this be what they would need to show Mr. Conlon in their work for these kinds of problems?
You just have to show me how to got the common ratio, say what that is. So this one was 5. And then you have to show the work for the next 3 terms. So just like we did there, we found our next 3 terms by multiplying by the common ratio. All right, so number 6. You guys can do that by yourself.
Tell me something about the pattern in this one. What's going on?
So negative, then it's positive.
Negative, then it's positive, then it's negative, then it's positive. So what should be happening in your next 3 terms? Should that pattern keep going? Get it? You want to check that out?
Yes.
Always good to see if you, what happened seems reasonable.
Wouldn't 96 times 2 be 192?
Yeah.
Yeah, probably would.
Good challenge.
Is it?
But then would 192 times negative 2 be negative 344?
384.
There it is. I totally meant to do that too.
Yeah.
Mhm.
We believe you.
Yep, everyone believes me, right? So what is
Sure.
negative 192 times negative 2 equal
384.
384? Thank you. See, you guys are paying attention.
Okay, so we shouldn't have to go through some check with you for
Yep.
one minute. Running out of time.
Okay, so. Does everyone have the same answers I do now that Isaac corrected me? Okay, so now you guys can move on to the next one.
Three thousand is the same as 1.5. So if you want to work with 1.5, can you? In fact, they give it in decimal name in the problem. So typically what we do is we keep up with the same type that they were. So I would recommend you do use the decimal name in this one.
This one.
Mhm. It's probably a sequence about money or something. Nope, no rounding unless the decimal doesn't quit. Does it quit? Does it terminate? Yeah, it's a nice terminating decimal, leave it all there. It doesn't say anything about rounding, so.
Alright, so. Everyone get the same common ratio I did? 3 halves and 1.5? Cool. And then, our next three terms. The silence is deafening, guys. Alright, Isaac?
I have a question.
Mhm.
For the second one, I just rounded it to 30.38. You cannot.
Nope, if it terminates to a nice decimal, you shouldn't write everything out. If it's repeating and goes on forever, then you can round,
No, then we're gonna run them as fractions.
or that.
Mhm.
Yeah.
Alright, so last question, and you guys can work on your homework. So,
Oh, go ahead, I'm sorry.
No.
I thought you were gonna tell me to work on this one.
yeah. So, you guys can do number 8 by yourselves.
What would be the most reasonable ratio to set up in this one? To say, so you'd be like, I don't really need my calculator.
2:1.
2/1, yeah, because you get to pick any term and its previous term. So 2/1 seems like the most reasonable one to work with, correct? So what is our common ratio?
2.
2. So the common ratio becomes the what? The multiplier, yeah, it becomes the multiplier to get the next terms.
Yes,
Do you want evens for all of them, or just 26 to 30?
just 26 through 30
Is what?
is evens. They're doing all through 2 through 4, so 2 through 4, 8 through 12, 8, 9, 10, 11, 12, and then 26 to 30 are the even ones, and keep track.